Welcome to the Actionable Futurist podcast, brought to you by Intel, all about the near-term future, with practical and actionable advice from a range of global experts to help you stay ahead of the curve. Your host is international keynote speaker and actionable futurist Andrew Grill.
Today on the podcast, I'm joined by Robert Halleck from Intel. Robert has always worked in the tech space, from humble beginnings in Geek Squad to hardware and smartphone reviews, and eventually to AMD, where he led marketing for AMD Ryzen processors as the Director of Client Technical Marketing. More recently, he joined Intel as a Senior Director of Technical Marketing for Intel Core Ultra processors. He now serves as the Vice President and General Manager of Client AI and Technical Marketing. Robert is a lifelong PC enthusiast and gamer, and his passion is to make hardware and technologies accessible and exciting for customers of all experience levels. AI, graphics, and processor performance are his specialties in this space. Welcome, Robert. Thank you for having me. Excited to be here. Look, we've got a lot to talk about today, and AI is the flavour of the month of the year, so we're going to talk a lot about AI. We're here to talk about the Intel Core Ultra and the Intel vPro platform with a specific focus on something that's really hot, and that's AI. But I was reading, in preparing for this podcast, Intel and Microsoft have co-defined the AI PC definition. So let's kick off with, what is an AI PC, and what are the business benefits for the end user and the business?
Yeah, so I guess sort of the motivation first helps support the definition. This whole AI PC thing is going to be a permanent transformation to the way computers are designed, the way that processors are designed. It'll help with performance and power efficiency, sort of the fundamentals that we all care about. So it's important that we all have a common understanding of what that is, so we can all work on it together and arrive in the same spot. And the view that Microsoft and Intel have is that this is a PC with a processor that has new hardware capabilities to run AI algorithms. And those capabilities will exist on the CPU cores, on the GPU cores, and a new class of accelerator called the Neural Processing Unit, or NPU. And there's different reasons why you would want to use one of those cores over another, but it all boils down to having the right tool for the job.
Now, the MPC was something that's new to me. We'll jump into that in a minute. But can you explain the significance of the Intel Core Ultra processors in powering AI applications and doing them locally on the PC?
Oh, there's so many advantages here. Starting, I think, with maybe the Pocketbook is a big one. Cost is a large component of running compute in the cloud, and AI workloads are vectorized or highly parallel workloads, and they consume a lot of compute, and that adds up to the bill at the end of the month. And so for users, that might result in one or more monthly subscriptions to cover the cost of those cloud services on powerful AI features. And for AI to grow, to expand, to bring the convenience and tools to more people, almost by necessity, it has to move locally to remove those cost barriers, because now you're just running it on the device you've purchased once and you're done. There are also certain classes of AI workloads that just don't work well in the cloud. Video is a big one. You're downloading multiple gigabyte project files. That's unsustainable. And then lastly, security and privacy is another big one. Corporations and even individual users have intellectual property that is private, and they want it to be protected, confidential. And by running this all on your PC, it's just on your computer, like any other piece of information. You're not farming anything out to a cloud service, and you've never lost custody. So those are sort of the three big motivators. There are more, but those are the most compelling ones.
We just talked off air about my new book, and in one of the chapters I talk about edge computing. Now, this is an excellent example of edge computing, because rather than going into the cloud, you're basically putting the compute where it's needed on the desktop in front of you on that workload. So maybe look into the business benefits. How does Intel Core Ultra enable businesses to leverage AI more effectively?
There's a couple ways early in the game that this can happen. The first is maybe a local large language model that everybody in the organization has. And this would allow staff to sort of automate the mundane tasks of being an information worker, drafting basic emails, taking meeting minutes, summarizing those meeting minutes, processing spreadsheets. These things don't take a high amount of skill, but they take a high amount of time to get done. And you can outsource that, offload that to a large language model on the PC and spend your time focusing on things that are more productive and more impactful. From an organizational level, there is a new technique, well, relatively new, called resource augmented generation, or RAG. And it allows a language model to be, I'll call it micro-trained on your company's data or your information. And so institutional knowledge is a really hard thing to preserve and protect in business. You know, a 25-year employee who's seen it all, if they leave, that knowledge goes with them, and it's very hard to protect it. But a RAG model could collect inside the corporate intranet your institutional knowledge, your learnings, and then all employees could simply query against that information and receive accurate answers back. So in the case of Intel, as an example, manufacturing a CPU is a highly iterative process, perhaps hundreds or thousands of steps. And how can any one brain remember everything that happened on step number 97, right? And how can you process the totality of everything that's occurred? What are the trends? What are the forecasts? A language model can help you do that when you have RAG. So now you're extending your knowledge, you're getting more accurate knowledge, you're making it more accessible to your company. This is just a couple ways that AI can help.
And because you've got the compute where it's needed, as I say, on everyone's desktop, you have a really powerful organization. You're leveraging what's in the LLM, but the processing you're doing locally, you're not waiting. I mean, I do a lot of video processing. You gave a great example there. I want the most powerful processor I've got to do it locally rather than farming it out, because I need to turn around things really quickly. I need that answer really quickly. So whether it's video, audio, those tasks you talk about, I liken sort of these generative AI platforms to be sort of an always-on intern. I've now got I've got intern inside, deliberately with the pun there.
Yeah, that's a really good way to put it. Digital assistants is a big category here. Information workers, I'd be hard to put a percentage on it, but I know even in my own life, administrative tasks take up a large portion of my day. And I've already started using LLMs to automate some of that, and it's been hugely helpful. I probably get an hour or two back in my working day as a result of offloading, and that allows me to worry about more important problems, like how is my team doing? Are they happy? Do they have everything they need? I can engage more quickly in the human side of the job, which I'd frankly rather be doing.
Yeah, everyone says that AI is going to give us more free time. I think people like you and I that are really exercising these tools are seeing the benefits. You put a number on it, an hour. I probably get multiple hours back a week. But I think as more and more people see that, they'll go, why isn't my company giving me an AI PC? I want to have that ability to do that and get those hours back.
Even if it's not a time component, you mentioned video editing. I myself come from an image background, and I'm just thinking about the number of hours it takes to convincingly remove an object from a scene, or frame by frame in 25 FPS video. It's extremely laborious, and AI-assisted masking, AI-assisted removal, AI-assisted rotoscoping, huge time improvement.
You alluded to it before, this NPU, the neural processing unit. It's new to me. So first of all, what does the NPU do? What is the role of the NPU in the Intel Core Ultra, and how does it help accelerate everyday AI tasks?
Well, let's start with the hardware people are probably familiar with. That helps set the foundation. CPU cores have AI instructions these days, and those are typically used for very low latency, very short running AI components, usually where there's like a quality of service or time constraint. And oftentimes that's the setup piece of a workload, an AI workload. Then you've got the graphics engine on the CPU, and for Intel, we call that ARC. And that GPU for many software vendors is used as the highest performance AI accelerator on the device. So that takes me finally to the NPU. So if the CPU is about latency and the GPU is about performance, what's the NPU for? It's about power efficiency. A lot of these AI workloads are going to become resident on the system and be long running. in the background waiting for your instruction or your request, and to run those with power efficiency, with both a performance improvement and something that doesn't take away battery life. The NPU needs to come into the system to handle that third category. It's a power efficiency play as these workloads grow. And this way we can bring the capability, but also extend battery life.
Does that really define the AI PC? You've got CPU, GPU, and now NPU. You have to have the three working in unison to really make the real benefits of an AI PC come to fruition?
I think within the last 3 months, that has become a consensus-driven understanding. Yeah, absolutely. And it's not by any one hardware vendor either. Intel was talking about this fairly early, but this is actually driven by the software industry. And that's a key point I'd want to make to listeners, that there's a lot of pull from software manufacturers who make some of the world's most popular applications, like Adobe Photoshop, Adobe Premiere, Microsoft Windows. They're all building AI features into their applications because they're able to build new stuff or make existing features faster. And collectively, companies like Intel have to build hardware to continue delivering performance and energy efficiency and good acoustics. So this is very much a pull. And that's good for the overall health of the PC ecosystem when there's broad support, but also it means this is a long-lasting trend because there's a demand here.
Yeah, absolutely. Businesses are going to want to see that, and it'll be like, you haven't got a fleet of AI PCs. You need to empower your workforce with that. Intel's a company that prides itself on innovation. So what technical advancements in Intel Core Ultra processors have facilitated this AI processing?
There's a couple components on the CPU side. I'll get nerdy for a minute. There's an instruction called VNNI, which was one of the first CPU instructions developed industry-wide to accelerate neural networking. So the NN in VNNI stands for neural networking. And Intel has had this in its CPUs for consumers since 2018. So some very early AI work there. More recently, the graphics cores, the Intel Arc graphics, gained a capability called DP4A. And DP4A is an instruction you add to a GPU specifically to process AI instructions with much higher throughput and lower power. And then finally, that NPU edition is somewhat GPU-like in that you have a large number of parallel math engines to run this code. And it only does AI workloads, unlike graphics, which can handle multiple workload types. So you extract additional efficiency out of that. Those are some of the three innovations in Core Ultra that make this possible. And then we'll continue building on those capabilities with future CPUs.
So let's delve down a bit deeper. So how do Intel Core Ultra processors optimize the different AI workloads compared to previous generations of Intel CPUs?
So if let's say you don't have an AI PC, it is actually still possible to run AI workloads because they will fall back to the processor cores. But for a conventional consumer CPU, you'd be giving up an extraordinary amount of performance to do that. To put a kind of a ballpark number on it, we're seeing somewhere between 5 to 10 times faster performance. So a literal order of magnitude by getting it off the CPU onto a dedicated accelerator. There's also a power advantage. We're seeing, again, 5 to 10 times additional performance for every 1 watt of power consumed. So that's a cool and quiet play. That's a battery life play. That's a make my PC easier to cool play. There are dividends all over here, but that's the benefit of having these specific accelerators. And I think personally, in say 5 years' time, what is widely considered a high performance, low power, efficient computer becomes inseparable from having an AI accelerator. It will become like a foundational component of how CPUs are designed industry-wide.
Could you maybe share some examples of innovative AI applications that are powered by Intel Core Ultra? You've mentioned the broader ones like video and graphics, but give us some ones that listeners might say, now I get it. That's why I need this AI PC.
One of my favorites is an application called Superpower, which should be available pretty shortly here. We've demonstrated it publicly before. This is so cool. So it records kind of any text you've ever seen, and it could be on a web page or a chat box, wherever. And then you can query it as a sort of a second memory. So if you emailed with someone 6 months ago and you cannot remember what you talked about or can't remember specific details, you can just pull up a summary of that conversation, or you can see the full conversation history if you wanted. Or if you're like me and you're chronically online and you see tidbits of information everywhere, but you can't remember the website you saw it at, you can ask it about the tidbit and it will fill in the blanks of what you don't remember. It'll tell you what website, it'll summarize the article. And then on top of all of that, it can draft emails, take meeting minutes, do summaries, and it's just like an all-in-one companion that just runs in the background on your PC. The other one that is interesting and perhaps less obvious is teleconferencing. Microsoft Teams, Zoom, WebEx. We've all had the virtual backgrounds or background blurring, and that has started to transition to AI. We're seeing 1 to 2 hours of additional battery life as a result of offloading those background camera effects from the CPU to an AI accelerator. And not only that, it makes the background segmentation look better. So you don't have like your ears disappearing or tops of your head getting cut off. They're more sophisticated. And maybe a third example for the enterprise is endpoint security. These security models are quite complicated and computationally intensive, and by offloading those to the NPU, we can see 10 to 20% of the CPU's performance returned to the user, and the security gets better. So those are a couple examples. So security, power, everyday activities, these are all taking advantage of AI.
Those three areas are music to ears of all different people in the organization, the CFO, the CIO, the CISO, and also the CMO. I love that first example of basically, I go back to that point of having an intern inside, being able to find things. That's all happening locally. That's basically supercharging everything on the AI PC.
That's correct. It is entirely local. You do not have to have an internet connection for it.
For remote workers, people that are running around having to find information, knowledge workers, that is so powerful. I think you're going to find people giving you examples of the hours that they've got back in their life, and they can finally find things without having to find an internet connection or on a plane or wherever work needs to happen, basically.
That's right. Well, I think we've all been in the situation. Perhaps we're new to a company or a team, and it's not really how long you've been there. It's who you know and who has the right information and right answers. And you can just dramatically expedite that with these large language models because it can be centralized and queryable. And now it's just like a chat box on your computer you can ask questions to. You don't need to track down the right person through a chain of people on Microsoft Teams. That's
so powerful. So we've looked at applications. Let's look at industries. How are industries transforming with these AI capabilities of the processors?
It's early days, right? So sort of call it phase one, content creation applications, image, video, audio, or even wholesale creation of image, video, audio are sort of the first wave because signal processing, image is a signal, sound is a signal, video. This is ripe for AI enhancement. So you'll see a lot of early adoption from companies like Blackmagic Studios who make DaVinci Resolve, Adobe, with, of course, the Creative Cloud. Phase two, coming very rapidly here, is the commercial adoption with these digital assistants, either locally on the PC or organizationally on premises with these RAG models we spoke of earlier. And then I think the third phase is probably general diffused acceptance of AI, whether people know it or not. It becomes sort of a common ingredient of what it means to be a PC. And somewhere in that phase three, I think PC gaming also starts to take on local AI capabilities as well for characters and text and voice and whatnot.
I was smiling when you mentioned Blackmagic because I'm encoding my video to you through a Blackmagic A10 Pro encoder. So, a bit of a video geek. So I can't wait to have that that capability even more powerfully enabled by an AI PC.
Yeah, some of the early features are really cool, if I may. Masking an object, right? You're going frame by frame for 25 frames a second times X number of video minutes. They have a new feature called magic masking that uses AI to just like you draw a line over the object you want to keep, and AI will scene detect everything around that object and mask it for you. And now instead of doing everything manually frame by frame, maybe you're just cleaning up one frame or another to get the edges right. But it's just a massive time saver.
What are some of the real world examples of how businesses are using AI capabilities in Intel Core Ultra devices today?
Well, security and those digital assistants are really the big two right now, because those are the perhaps most difficult challenges to solve. And I'll touch a little more on security because we only brushed by that one. Yeah. Most of the attacks in an enterprise now are fileless, which means it's not a virus compromising an executable file anymore. These are exploits that are resident in memory. And that's extraordinarily hard to detect because you're not checking signatures of a file before and after anymore. You're looking at the patterns of memory, which are changing all the time as the user loads apps and closes apps and files. And so now a lot of these endpoint services like CrowdStrike, which Intel has been working with on this NPU experiment, we're using advanced AI models because AI is extraordinarily good at detecting patterns in the ways that conventional algorithms are not. Conventional algorithms just can't do this well. But AI is by design sort of imaginative and intuitive. So we offload this convolutional neural network, or CNN, from the CPU to the NPU. And in the CrowdStrike example, the user gets 20% CPU performance back. So running this on the processor cores just skims 20% right off the top because it's a tough problem and it takes a big model. Put that back on the NPU. You get less memory usage, so performance is improved. And you get CPU usage back, performance is improved. And the security model, because it now has a dedicated resource, it's not sharing, it gets better. You can make the model more advanced. So we're also exploring this for phishing detection, automatically catching phishing emails, endpoint detection, premises detection of threats. There's a lot of security benefits here. There's also the idea of there's two related concepts: security for AI and AI for security. Okay, so the first couple of examples are AI for security, but now you also have to think about if the user has their conversation histories and their information on their PC, similar to Outlook, but now more personal. You have to bring up a number of technologies inside the CPU and at the software layer that can better protect that information for users. So this is the security for AI component that vPro is bringing to the table, where you have things running both above and below the operating system that are that much more important when you've got all this personal info locked up in an AI app.
Yeah, I think a lot of listeners, a lot of podcast listeners don't realize the security implications, and having something running locally, being able to actually look all through not just the files you say, but what's actually happening in memory without a performance hit is so important. And I think those bad actors listening are going to be a bit upset because it's now going to become harder and harder because you've got all this extra computational power at the source checking for bad things.
Just as an example of extra computational power, AI performance can be roughly estimated in a number called tera operations per second, or TOPS. And this is just a mathematical calculation of the engine performance, but a CPU might have a couple TOPS of AI capability, whereas a GPU might have 20 to 30, and an NPU might have 20, 30, 50 tops, right? So we're talking, 25, 30 times more performance by offloading these models to the CPU from a raw throughput calculation point of view. So there's a lot of headroom here to make these models more advanced and more performant to give better experience and better features.
So there's now a lot going on the device. So how do Intel Core Ultra processors decide whether to run an AI workload on the CPU, the GPU, or the NPU to get that best performance?
The interesting thing is that it's often the software developer that decides. They all have their own KPIs of how they want their software to behave. In the case of teleconferencing, they understand that people will be on their computer doing this for hours. And so for them, power is the most important thing, extending that runtime. So they're very much focused on the NPU. And content creation companies like DaVinci, Blackmagic Design, and Adobe, they're all about fastest time to completion, throughput. And so the GPU is the choice for them. And for the developers that don't know, Intel has a tool called OpenVINO, which is both a AI development framework to assist in building and deploying. And it's also a runtime, or the environment that these AI models and AI applications can run on top of as a helper. And OpenVINO can often make the decision for you if you're not sure when you build the application.
So you mentioned OpenVINO, but what other developer tools and resources does Intel provide to help these software teams and developers optimize the AI models for Intel Core Ultra architectures?
Yeah, software is the name of the game. I could spend all day talking about the software. It's actually more important than the hardware here. So if you think about a layer model, there are many layers that are required in software land above the operating system to get AI software working. From the development end, you have multiple frameworks that are in play across the industry. And those frameworks have pros and cons about performance and features, and oftentimes it's just developer preference. But from the Intel side, we have to make sure that we work with all the major frameworks. So when a developer chooses one development environment over another, they have a good experience on all of our engines. The next layer up from that, you've got runtimes, which are an environment that apps run on top of. And Microsoft has Onyx as an example, ONNX. We have OpenVINO, which can also run through Onyx. There are lots of examples in this space. And again, same software challenge. Because there are so many choices, we have to support all the popular ones, all the big ones, so developers have a great time. And then above that, it gets really interesting. There are hundreds of AI models. And right now, Intel has by far the largest selection of optimized models at about 515 from 4 different sources, like Hugging Face and PyTorch. And so that just makes it easier for a developer to find a model and run a model that does what they want. And then you build the application on top of that. And all of that is a long way of saying there's an extraordinary amount of software choice in this space, and Intel has to be involved at pretty much every layer from the OS up to make sure that this runs well, that the device can actually deliver you the tops of performance that are theoretically possible. The software makes that happen.
So we've talked about AI and security, and I really understand what's happening locally, but let's bring into this the Intel vPro platform into the mix. So with the integration of AI, how do the Intel Core Ultra processors add to the data security offered by the Intel Pro V platform? How do the two work together for maximum effect?
There's a couple. We have a technology called Intel Threat Detection Technology, TDT, which is sort of a back end that software developers, security vendors can plug into to improve the accuracy and robustness of their security solution. You have standard stuff like memory encryption, hypervisors. You have disk encryption. You have virtualization capabilities, sandboxing capabilities. Like, this is an extremely large software stack, and not every vendor is going to use every feature. But the point is that security starts really from the second you press the power button on your PC. There are now firmware level attacks and boot time attacks and the OS is loading attacks and attacks inside the OS, and you have to protect every layer, which requires software IP and hardware IP to make sure detection and prevention is possible. And that's what vPro fundamentally provides, security from the time you press the power button.
But with the AI PC locally, with the Intel Core Ultra PC on the desktop, the two together, it's unbeatable, isn't it? It's unmatchable.
Yeah, it's an extremely strong software package. Right now, Intel is the only company talking about AI for security and security for AI, which tells me sort of implicitly or by process of elimination that we're the only company with the R&D and the investment in these areas. vPro is a critical piece of our processor business. We're, I think, the majority player in that space. I think that's fair to say. And it's our crown jewel. So we want to continue extending this into the AI space.
So these processors are now pretty important for what's going on. So how is AI enhancing the security features on the actual processors?
So on the processors themselves, there are increasingly very small AI models, not really for security purposes, but there are ones for performance enhancement purposes. For example, our frequency management technology now has AI components, so we can extract more performance for every watt of energy consumed. I think it'll be a while still before AI is actually sort of built into the CPU for a security point of view, because those models are so complex, it would be challenging to fit them inside the CPU microarchitecture. That's better served by firmware, software, operating system, etc.
So I'm an IT professional. I'm hearing the podcast. I'm thinking, yeah, I need to look at a business case for getting these AI PCs out into the estate. It's a really important thing. We can look at, power optimization, workflow optimization. We can get hours back in the day. We can be more secure. So you've sold me there. But as an IT professional, what types of AI use cases should I look to deploy first that are actually really well suited to Intel Core Ultra's capabilities?
Let's see here. I think so if you're an IT DM, this is my Intel. Hopefully I can bring it up here. Here's my Intel work laptop, and that has CrowdStrike from it, preloaded from Intel corporate IT. And so when that NPU offload hits production, I get performance back, I get power back. This is abstracting for a moment. I am an employee at a large company with a large IT organization, and they rely on CrowdStrike for endpoint security. I do believe these digital assistants, be they coming through Microsoft Windows in Copilot or through one of these third-party companion apps like Superpower, I think that will be huge. I think that Copilot, as another example, has already shown promise for analyzing spreadsheets, creating PowerPoints, creating documents. A lot of the stuff we make is information processing, doesn't need to be super polished, and you can take a shortcut there. And this is all happening very quickly. By first half of this year, these tools will be broadly available, and widely, you can just go download them and try it out. What
are the new experiences the user can expect from an AI PC?
There are hundreds, so I will shorten it to say intel.com/AI PC. We've been documenting all the new features and software there that use these AI accelerators. You can see demo videos, you can see what applications are there. There's lots of material you can check out. In total, this year we're planning on 100 different software vendors working with our Core Ultra processors, and we intend to deliver about 300 different AI features spanning consumer and commercial space. And that is on top of the AI features that have been developed since we first started doing CPU-only AI in 2018, which includes for example, the Adobe suite. They've been a very early adopter. So hundreds, check out Intel.com AI PC. That's the best place to go.
So the whole concept of an AI PC is fairly new, as you've said. How will I know I'm actually using an AI PC?
There's a couple easy ways to do that. Software vendors, I'm sure, will tell you that they've updated their application with AI. It's admittedly a buzzword in the industry, but there's a large appetite for it. We've also taken the step in Task Manager, Windows Task Manager. If you open it up, you can see the CPU, GPU, and NPU. So if you've got an app that's hitting any one of those, you can just see the activity level right with a built-in Windows tool. And those are probably the two easiest ways to do it.
Do companies really need their workforce equipped with an AI PC?
I think they increasingly will. And, I don't want to say this is a total instantaneous transformation because that's not realistic or fair. But I think incrementally, it would be very wise for organizations to start factoring these into their workforces. The information analysis components of AI would be very big for an iterative engineering organization. The content creation components of AI would be very strong for marketing and communications departments, copy editing departments, ITDMs. We talked about security. There are myriad benefits here. And then, the thing I'd also want to communicate is that AI will continue to evolve and become, in a 4 or 5 year time span, an indispensable part of power and performance. So organizations that are reluctant or slow to adopt these capabilities are going to be upside down competitively on fundamentals like battery life and performance, which are the hallmarks of purchasing decisions in an IT department, right? We're all seeing tenders and they want X performance level. Well, a lot of the classic corporate software is rapidly adopting AI, and it will put you at a competitive disadvantage not to have it.
So I want to drill down a bit more on that performance and efficiency, because sometimes that's what makes the decision a lot easier. How do Intel Core Ultra processors balance high performance with efficiency with AI tasks?
That's really what having this 3 engines is all about. So we could consider a couple hypothetical universes. Let's say that AI only continues to live on CPU. All right. In processor design, there's this concept of race to idle, which is how quickly can you get through a workload and then go back to the lowest possible power state. And the faster you can do that, the more efficient you become, the longer the battery life. And if you put these AI workloads on the CPU cores, they would run, but it would take a very long time for them to run. And now you have a CPU just number crunching for a very long time, which is consumptive to power, institutionally shows up in your power bill at the end of the month. For the user, it shows up in loss of battery life or a less quiet PC on their desk, which are all unhappy outcomes. Or let's say you run it on GPU. Okay. Very fast, very high performance. But as models and applications tend to become more resident on the PC, the GPU consumes more power than the NPU. So now you have these long-running activities completing very quickly, but they're using more power than they should if you had an NPU instead. And that takes me finally to the NPU, where you can sustain these long-running activities while boosting performance and battery life and power efficiency and, right? You get all the classic benefits of a new CPU microarchitecture, plus the AI capability as well. You're adding without taking something away. And if you did not design an AI PC this way, there would be compromises. So at the end of the day, we're all trying to advance the fundamentals like performance and power, and AI is simply the new battlefront in that space.
So I'm a futurist, so we have to talk about the future of AI with Intel. What future advancements can we expect from Intel regarding AI processing and Intel Core Ultra processors?
Well, the thing I'd want to say is this market is a lot like PC gaming, actually, and in that every year you see a new, faster GPU, you get faster drivers, you get new exciting games, you get new software, and AI in these respects is very, very similar. Even the number of software layers and what they do is very analogous to GPUs and gaming graphics. So you can think about how gaming has evolved over, I don't know, since the Atari or even earlier, right? It's just been this extraordinary pace of innovation. And because it's so similar and so familiar, a lot of that time can be compressed into AI, into the AI timeline. And we think that by 2028, 8 out of every 10 computers will have AI accelerators, basically top to bottom coverage in the market. And that means the vast majority of people, whether they know it or not, are using and benefiting from AI. And that's less than 4 years away. So this is happening extraordinarily quickly in the PC space.
Lots of AI developers out there wanting to put their applications on the desktop, on the AI PC. So how's Intel working with the AI developer community to drive this innovation?
A lot of it is open source or multi-vendor. And that is one of the advantages of being at Intel. We have probably the largest software development, software co-enablement organization of any processor vendor. And so that allows us to take on more projects, more open source projects, more software co-development projects. And it essentially comes down to bandwidth. The more bandwidth you have as an organization to help optimize, design, deploy, the wider your software stack and the more attractive you become as a development target. At a top level, we want to be the scale provider for AI PC. Largest install base, largest number of applications, largest number of frameworks, runtimes, you name it. If it's an element of importance in this space, we want to be the biggest and the mostest. And, it seems so easy to say it that way, but it takes an enormous amount of work and engagement and hard-nosed engineering time to make it possible.
So it leads me to my next question. How will the inclusion of AI acceleration in Intel Core Ultra impact the development of future AI applications and models?
Ooh. I think the software industry is broadly recognizing that they want AI in their application, and to what extent will vary by software vendors. But AI can do, just to touch on some of them, it can turn speech into text, text into speech, very realistic human voices, text into video, text into music. You can create images from nothing. You can just describe what you want. You can do object recognition. You can classify images by computer. You can clean up images and supersize them. You can do that to video. Like there's hundreds, thousands of models out there, and more coming all the time. And yes, it is difficult to imagine what it's going to look like in 2 to 3 years. And PC gaming had the same problem, but continuous evolution has proven that there is always something interesting around the corner. And I expect the same thing from AI. And this is probably the one place that is extraordinarily hot in software development. It is, yes, it's a buzzword, but it's a buzzword because there is a lot going on under the surface. People are talking about it because it's here, it's real, and it's extraordinarily compelling for both hardware and software makers.
But now for these developers, their vision can be realized because they've had these crazy ideas that have required a lot more compute on the desktop and at the edge. So now they're going, thank goodness, we've now got that compute power. I can do some amazing things and help my users out. So let's stretch you out 5 years. What's Intel's vision for how AI capabilities and devices will evolve over the next 5 years as Intel Core Ultra processors continue to advance?
Well, I think what you see from AI models is that there's a march for increasing complexity. And I'll just take large language models as for a moment. They have what's called parameters, and parameters measured in billions or tens of billions, depending on where you're running, determines how clever the model is, how intuitive and creative is it, how good is it at common sense reasoning or solving a problem or writing code or many other categories that we take for granted as humans. And as these models get increasingly ingenious and complex, that requires a parallel improvement in performance of the silicon to support those new capabilities, just like new games might require newer, faster GPUs to bring all the best features. So fast forward 5 years, computational quantities have gone up significantly. How much? Hard to say. We take it a couple years at a time, but we're seeing a many-fold increase in computational capability on both GPU and NPU. I think those engines become widespread across the industry from all the processor vendors and in all the different PC segments. Because remember, today, AI is just sort of mainstream or low premium notebook. It's not in desktop. It's not in ultra premium notebooks. It's not in the most affordable systems, right? So now we're talking verticality and horizontal deployment of AI. And then you see much, much more sophisticated models. For example, being able to generate video has already started. Not just editing a video, but creating it from nothing has started. And then we'll see. One of Intel's privileges is that we're an R&D platform for the world's software developers. In truth, we don't make models or applications of our own for the most part, except to show the possibilities to other people. But we help the other people bring their dream to life. And we can do that by being the most robust hardware platform, having the most devices, making it the easiest to develop on Intel hardware. We'll see how it goes.
Yeah, what I'm looking at, what's coming next with AI, it's so exciting. I mean, with OpenAI launching Sora, which is, as you said, that text to video, announcements this week about both OpenAI and Meta saying they're going to add reasoning into the platforms. I can't wait for that because a lot of the systems I use today tell me something, but they have no idea whether what they're saying is reasonable and actually accurate. So reasoning, it's going to require a lot of computational power, but I think humans want that because they're sick of reading something that they know is false. But a bit like that intern that quite confidently tells you something that's wrong.
Yeah, it's true. Accuracy is a tough challenge in AI for the large language models, and that is another reason why multiplying the hardware capability is extraordinarily important, and why models are evolving. We're not just making them more clever or able to answer a wider range of things. We're also making them more accurate. And, I talk to people who aren't into AI and they're like, well, why is this piece of software giving me a wrong answer? I'm like, well, because an AI replicates human thinking and human knowledge, and humans can also be wrong. We are fallible. And so, we're trying to make a less fallible, less wrong, human analog. And that is a very interesting philosophical problem in AI.
That's for another podcast. I talk to both educators and students about the need to retain the ability to critically think. Just because you've got an answer from a machine doesn't mean it's right. You need to. I started debating as a young student, so I love that critical thinking. We are almost out of time, though. We're up to my favorite part of the podcast, the quickfire round, where we learn a bit more about our guests. And I've had a fascinating discussion, so I can't wait for your answers to these simple questions. Okay. Window or aisle?
Depends on what time the flight is and how long it is. Can I say that? Can I say that?
It's a morning flight.
Oh, window.
And it's over the Atlantic.
Window, because I want to put my head against the wall and sleep.
Your biggest hope for this year and next?
Biggest hope for this year. Intel has some, I'm going to talk about work for a sec, but we've got some new CPUs coming up. One's called Lunar Lake and one's called Arrow Lake. And these attack a few different new segments in the market and build on the AI PC thing. They are extraordinarily good CPUs. First and foremost, I am a technologist. I came from a hardware review background. So it just personally excites me as a PC user to see great hardware being designed. and I am over the moon. I guess that's a stupid joke. Over the moon about Lunar Lake and Arrow Lake to see this come to market. Yeah, not intentionally, but here we are.
I wish that AI could do all of my...
Laundry. The first company that produces an AI robot that can do my laundry and fold it for me, I will buy.
You're the fourth guest in as many months to answer that question the same way.
Not clever.
What's the app you use most on your phone?
The most used app on my phone is probably the web browser, which is such a plain answer, but I think that's true for most people.
The best piece of advice you've ever received?
Okay, so my wife is in medicine, and I got a piece of advice from her early on that, I'm paraphrasing, but she said something to the effect of, there are C students in every profession, including the ones that work on your heart. And somewhat eye-opening to me. And that has changed my relationship with how I think about healthcare and what I will and won't tolerate in treatment. I'm nearly 40, so I've lived long enough to have medical injuries and problems, and that has really opened my eyes.
I'm hoping your wife's an A student.
She is a wonderful student. Yes, absolutely. She leads a department here in Austin, Texas, in the emergency room. What
are you reading at the moment?
Let's see. I'm currently reading Contact, the book Contact, and interestingly, I think the movie's better. I'm about 3/4 of the way through, which might be heretical to some people, and also starting my 11 billionth reread of Lord of the Rings.
Who should I invite next onto the podcast?
Easy answer. I have a colleague, razor sharp. Her name is Carla Rodriguez, and she's in the software organization at Intel. So a lot of the AI PC software work that's going on across the industry, she is directly involved with, and she's just so smart, so capable. I would love to hear her podcast.
That sounds like a super exciting guest. Last quickfire question. How do you want to be remembered?
I want to be remembered as a good human, which interesting, difficult problem. But, I've led a team in corporate America now for 6 or 7 years. And I quickly realized that empathy is the most important tool. It's not about the work. It's not about, the job. It's about how happy people are to come to work and do the job. And, I want my people to go home happy and not feel like work is a burden. And by extension, I want to be that human to my friends and to my family. I don't thirst for money. I don't thirst for possessions. I want to be remembered as a good person.
Bring it back to AI. All the AI experts I've had on the podcast have said there are two things AI can't feel: empathy and love. So what you're doing is a really great thing. As this is the Actionable Futures podcast, what 3 actionable things should our audience do today to better understand the power of Intel Core Ultra and the Intel vPro platform?
Okay, so intel.com/AI PC is action number 1. That'll kind of bring you up to speed on what's going on in AI land. And we have some updates coming that'll sort of spell out all the different software components that are going on. So if you're just wondering how this works on PC, that's a great place to go. We just launched Intel Core Ultra for vPro last month, I believe. So there's a round of media coverage I encourage people to look up because we've got some new technologies, new features, and it's a very up-to-date look at what's going on in the enterprise and how new CPUs can help. And then the last thing I would recommend is keep an eye on the back half of this year. Those Lunar Lake and Arrow Lake CPUs are, again, extraordinarily good. And, maybe if you're not ready to jump into a refresh right now, maybe your cycle's on the back half of the year, and we've got some really cool stuff coming. So those are the 3 things I can think of. And of course, if anybody has questions, I'm on Twitter, and I'd love to chat about AI.
Look, this has been a fascinating discussion. So how can we learn more about you and your work beyond Twitter/X?
LinkedIn, actually has rapidly become one of my favorite social media platforms, which was somewhat surprising to me. But Twitter has changed a lot, and I'm liking the adult conversations on LinkedIn. It's still a very nice, germane, friendly platform.
I joined LinkedIn in 2003, I think it was, or 2004. So I've been on there for a while. It's my go-to place. It's where I get a lot of insights and information, and certainly following you. So thank you so much for your time today. I've learned a lot. I think AI is here. It's real. And with Intel behind, it's going places.
I definitely think AI is here to stay. One parting comment is I think there's in certain groups a high degree of skepticism about AI, that it might be temporary, but the one thing I'd say is that this is a permanent transformation to CPUs and system design. This is going to be huge, and whether you buy in now or 5 years from now, this is going to become fundamental for performance and power. So I appreciate the opportunity to be on the show, and good talking to you.
Thank you for listening to the Actionable Futurist podcast, brought to you by Intel. You can find all of our previous shows at actionablefuturist.com. And if you like what you've heard on the show, please consider subscribing via your favorite podcast app so you never miss an episode. You can find out more about Andrew and how he helps corporates navigate a disruptive digital world with keynote speeches and C-suite workshops delivered in person or virtually at actionablefuturist.com. Until next time, this has been the Actionable Futurist Podcast.